Welcome back. So today we'll try to learn how to find value of determinant of any size more than 2. It could be a 3 by 3, 4 by 4 or n by n. Whatever may be the size of our determinant, we can find its value using this method. Remember, 2 by 2 is solved using another method that we learned in previous two videos, while anything above 2 by 2 can be solved using these methods. So first we learn a simple one of size 3 by 3. The the tricks remain same for any size. Let us again make a very small, very easy determinant of, let's say, 1, 2, 5, 3, 2 and 1, 4, 1 and 5. Now, what have we done? We have taken a determinant of size 3. Next, always, I'll write down all of the columns once again over here in this space, just excluding the last one. So what I'll do is I'll write down these two columns in this space, excluding the third one. Third one in this case, or in general, I can say I'll never reproduce the last column. I'll always omit the last column and write down the remaining columns, starting with first to n minus 1. So here I have 3 columns, so I'll be writing 2 columns. If I have 5 columns, I'll be producing 4 columns. We'll learn these things in a moment or so. For now, let me write these columns. 1, 3, 4. Done, first column. Then second column was 2, 2, 1. And as far as this column is concerned, we already have a rule. We never write down this column. So I will only be writing this column and second column. Done. So what we have done is we have rewritten first two columns. Now let us go ahead. The trick would be kind of similar to the previous one that we learned in 2 by 2. What do we have? See, we have a diagonal 1, 2, 5. Then we have a diagonal 2, 1, 4. Then we have a diagonal 5, 1, 3. So what I'll do is I'll multiply them and add them. I'll multiply them and add them. How? Let us see. This is equal to, let me open a bracket, a big bracket, where I'll be multiplying 1 multiplied by 2 multiplied by 5. 1 multiplied by 2 multiplied by 5. Plus the second diagonal. That is 2 multiplied by 1 multiplied by 4. 2 multiplied by 1 multiplied by 4. Plus the third diagonal. 5 multiplied by 3 multiplied by 1. 5 multiplied by 3 multiplied by 1. Oops, we did not remove this thing. Okay, 5 multiplied by 3 multiplied by 1. Done. We are through with all three diagonals. 1 multiplied by 2 multiplied by 5. Then there was a 2, 1, 4. Here it is. Then there was a 5, 3, 1. Here it is. So what we have done is we have written all three leading diagonals. The diagonals that are bringing us from top to the bottom. Now, as we were doing in 2 by 2 case, we have a bracket ready. Now what I'll do is I'll put a very small, I'll put a minus sign. Again, I'll put a minus sign and start a bracket. This time what I'll do is, last time I was taking the top and climbing down. Now I'll be starting from bottom and going to the top. So what do we see? We see a 4 multiplied by 2 multiplied by 5. The next one will be 1 into 1 into 1. And last one will be 5 multiplied by 3 multiplied by 2. Let us go ahead. 4 multiply by 2 multiply by 5. 4 multiply by 2 multiply by 5 plus the next one. Next one is 1 multiply by 1 multiply by 1. 1 multiply by 1 multiply by 1. And last one would be 5 multiply by 3 multiply by 2. 5 multiply by 3 multiply by 2. Done? So what we have done is we have multiplied all the leading diagonals, 3 leading diagonals. We can see 1, 2, 5, 2, 1, 4, 5, 3, 1. Then we multiplied all the trailing diagonals, that is 4, 2, 5. Here it is. Then 1, 1, 1. Here it is. And then 5, 3, 2. Here it is. So we multiplied all the leading diagonals and all the trailing diagonals. Now let us just go ahead and solve it. It is simple mathematics. What do we have? 1 multiplied by 2 multiplied by 5 would give me a 5 2s are 10. This would be a 4 multiplied by 2, 8. This would be a 5 multiplied by 3, 15 minus. We have 4 2s are 8, 8 5s are 40. Then we have a 1. And this would give me a 5, 3s are 15, 15 2s are 30. So I get a 10 plus 8, 18, 18 plus 5, 33 minus 40 plus 1, 41 plus 30, 71 minus 71. If we remove the brackets, we get a 33 minus 71. So what is the value of determinant finally?